Okay. Good morning, everybody. So today I wanted to talk about a concept called virtual private cloud. It's something that you've been using already, but you don't know that it exists in the background. So by default, when you create your AWS account, a virtual private cloud, a VPC, or they call it default VPC, gets created automatically. So what exactly is a virtual private cloud? And we don't have to be stuck with the default VPC. We can create our own VPC and we can play with it. That's what we are going to do today. Okay, and these concepts are somewhat complex for non-networking people. For networking people probably it's pretty straightforward. But don't worry. I came from development background, so I have no idea about networking. So don't worry, we'll learn together. Okay. So what is Amazon VPC? I actually got this from the Amazon website itself. I'll explain what it is. So Amazon VPC enables you to launch AWS resources into a virtual network that you have defined. This virtual network closely resembles a traditional network that you would operate in your own data center with the benefits of using the scalable infrastructure of AWS. So you guys are already using it in your workplace. Okay, so you have a separate network department. So those networking people create this segregation of the resources. So they'll create one big virtual network. Okay, all of your resources in your organization together, they create one virtual network. And then within that, they logically group them. Okay, these 100 are web servers, these 50 are database servers, these 50 are Hadoop servers. So you can separate them. You can logically group them so that you can define your rules, who can talk to what, how the network packets traverse through. So you're able to do it in your own data center, in your own in your organization. You're able to define your own IP ranges for each logical group of IP. They call it subnets. You're able to do all of that because that's your network. Everything, you have the full control in your office network, right? How can you do it in AWS? Well, yes, even though it's a multi-tenant, Amazon lets you do it. Not only Amazon, actually, almost all of these cloud providers, they let you do that. So Amazon calls it virtual private cloud. So with that, you will be able to pretty much, this will resemble what you do in your office. This is like a virtual network. So you will have your own space, networking space, and then you can separate out. You can write your own route tables, and you can provide the rules, network rules, saying that this server cannot talk to anyone outside of this group of servers. So you can write that. Okay, and who will have internet access? What servers can have internet access? Who cannot have internet access? Okay, so who are public outside of your network? So something like web servers. Web servers have to take the request on port 80 from the entire world. So they have to be in that demilitarized zone, DMZ, that's what they call it. So they have to be able to take the hits from the outside. But that's not the case with database servers. The database servers, nobody should be talking from outside, because nobody can request the database from outside. So everybody has to come through the front door, meaning everybody has to come through the web server. And then web server only can talk to the database. So we'll have that separation. Okay, we have that, you may be thinking that through security group we have to an extent. Yes, we do have the security. But the concepts that I'm going to show you today, they'll take you to the next level, not at the instance level, but the whole logical grouping level. They call it subnet. So without delay, let me go to the next, some of the concepts before we try to dive into VPC. Let's understand some of this terminology. So VPC is a virtual network dedicated to your AWS account. Okay, so you can create multiple VPCs. It's typical to have multiple VPCs, one per environment. Let's say you have a QA and prod environments. Okay, and it's a good idea to create 2 different VPCs so that all the resources within that VPC will not talk to the resources outside of that VPC. Well, you can do something called VPC peering. We'll talk about that later. But essentially, they're completely separated out from each other. So that's how we typically architect it. So that's about VPC. So within a VPC, another concept that we need to understand here, it may not be straightforward for a lot of us who come from development background. A subnet is a range of IP addresses in your VPC. So within a VPC, we will create multiple subnets. Subnet is a range of IP addresses. So we will give certain range of IP addresses to one subnet, meaning one logical grouping. And we will say, all the web servers reside in this one. All the web servers will get this kind of IP range. All the database servers will get a separate IP range. Okay, and there is another concept called route table or route table. Okay, it's another networking concept. Route table contains a set of rules called routes that are used to determine where network traffic is directed. So it's nothing but the rules. We're going to do that today. In the route table, essentially you define the rules saying that, and you will, that logical entity called route table, you associate that to a subnet, meaning a range of IP addresses, saying that these guys, all the AWS resources sitting in this particular subnet, their network packets, this is how they can talk to. So you define the rules. So if they want to get internet, by default, they do not get the internet. But if they want internet, every packet should go through this proxy. But essentially, you define the rules and attach it to or associate it to the subnet. I'm going to show you how. And another concept here is called internet gateway. An internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. Internet gateway is like a front door for your complete, VPC. If somebody from outside of your VPC wants to come and talk to any of our resources, it has to come through the internet gateway. Or if any of your resources need internet connection, if you need something from outside, then it has to go through the internet gateway. So your internet gateway has to be attached to the VPC, then only you will have internet connection. Otherwise, no internet connection. Well, without having internet connection, all these resources can talk to each other within VPC, no problem. But you will not be able to connect to it from your machine because you need internet, because you are trying to access from outside the world. And all those resources also will not be able to, let's say, update their operating system, sudo yum update. They'll not be able to do it because they cannot go out. They don't have internet. Now, if you need internet to your VPC, then you have to create an internet gateway. It's again a VPC component. You don't have to, it's a managed component. You don't have to log in. You don't have to do anything. Just create it, attach to your VPC, and then give your route table. Define your rules that, everybody must go through this internet gateway. Okay. And then attach that route table to a subnet. Then all the resources that are sitting inside that subnet will be able to talk to internet now. Okay. So internet gateway, again, I got this directly from Amazon website itself. So an internet gateway is horizontally scaled. The reason they mentioned is that you don't have to worry about, can it scale my band? Can it scale to my bandwidth requirements? Absolutely. Even if you have, 10,000 servers trying to go out and get the packets from outside, meaning trying to connect to internet, or outside people trying to come in. So Amazon will automatically scale it. You don't have to worry about internet gateway. It's horizontally scaled and they will take care of it. You do not have to worry about it. Okay. So it therefore imposes no availability risks or bandwidth constraints on your network traffic. You don't have to worry about it. So any questions so far?
Venkat, quick question. Suppose if so you have a VPC and you want to talk to third-party vendor, like not internet, but third-party vendor. So they have to go through the internet gateway.
Yes, there are a couple of ways actually. So if you want to talk to, rather than talking to internet, or in addition to that, okay, let's say you are using AWS as an extension to your own data center. Let's say you have some resources within your data center, but you're using AWS as your cloud partner as an extension. In that case, you will be able to connect through VPN. Okay. And with you, and you have another access, another component called direct connect. Using direct connect, you'll be able to talk to other resources. But if you are wondering how can I talk to resources within my data center, talk to the resources in the cloud. Okay, so you do it through VPN, and then you have a direct connect. And then let's say you have one VPC. And you have a second AWS account, and there is another VPC there. And how can they talk to each other? There is something called VPC peering. So we have these options. Make sense, Srinivas?
Yeah, thank you. Yep.
Okay, so this is what we want to do. So you have a region. Oh, by the way, VPC cannot span multiple regions. So when you create a VPC, you will have to create that VPC within a region. So all along, you've been playing in Ohio region, right? So when you created this account, you already have, Amazon automatically created a default VPC for you. But if you have to create a new one, so it will be within a region. So within a region, and you have the concept of availability zone, right? So now within an availability zone, you can have a multiple subnets. You can divide at the network level, saying that, okay, certain IP ranges will go into this subnet, and certain IP ranges will go into this subnet, and I'm keeping all my web servers here, and I'm keeping all my database servers here. Okay, my web servers need internet connection, but database servers do not need internet connection. And well, the internet traffic cannot come into database. Okay, so, but at least they need internet connection, the outbound internet connection, so that they will update their database. They'll update their operating system, OS patches, or database patches, or they want to do minor version upgrade. How can I do that? Well, I'll find out. I'm going to show you how you do that. But essentially, but the one key point here is that the subnet cannot span multiple availability zones. one subnet can be in one availability zone only. Subnet cannot span multiple availability zones, but you can have several subnets within a single availability zone. The reason is, these are logically grouped IP ranges, meaning logically grouped Amazon resources, right? You want to keep all the logically grouped Amazon resources to be in a single data center, single availability zone. Okay, so let's say US is 2A. In US is 2A, that's an availability zone. You can have a public, you can have a public subnet and private subnet. Again, in 2B, you can have a public subnet and private subnet. The reason I'm calling it public subnet is a subnet is called a public subnet when it has internet connection. When outside traffic, actually, let me rephrase that. When they're open, or when they can take the request from outside of the VPC. So if they can take the request from internet, then they are called public subnet. All these web servers, they must be able to serve internet traffic. But the database servers, no, they do not serve internet traffic. They do not take requests from outside of this VPC. Does that make sense? They will only take requests from web servers.
Okay.
Yes.
So, but database servers will can send requests outside.
Database servers need internet connection to at least be able to install your MySQL server, let's say, okay, yeah, and be able to update it, or be able to update their operating system. Absolutely, they need internet connection. How can they get it? They by default they don't get it, but there should be some strategy that should allow you to do that. You understand what I'm saying?
Yeah, yeah. So because yeah, I'm sorry, go ahead.
Yeah, I'll make this point and then I'll let you speak. So we talked about the concept called internet gateway. So whoever has a route to the internet gateway will have internet connection, but database servers will not have route to the internet gateway. The internet gateway will be sitting here. There will be one internet gateway for the entire VPC that's acting as a proxy to take the request from outside or to send the packets outside. Okay, and in between, I'll mention some concepts called network address translation, and there are a couple of ways you can do it: NAT gateway and NAT instance. I'll show you how you can do that. But first, let's start with this one. I want to start with something simple. Does it make sense? So your internet gateway will be sitting here. So this guy, actually, I'll show you here. See here, this diagram I pulled from Amazon itself. See, internet gateway is sitting here. So internet gateway, you will create an internet gateway attached to your VPC. So when a request comes from outside of the VPC, from somewhere from the internet, okay, your internet gateway is acting as a proxy, takes every single request, and then there is something called a router. We have a router at homes, right? So that router does the same thing. So if you go log into your computer and if you do ipconfig, you will see your private IP 192.168.0. something. Okay, and you can create your own LAN, local area network, so that all these systems, they can talk to each other. But when you need something from internet, it goes through the router, and then router does something called network address translation, meaning it is acting as a proxy, saying that it masks whoever the original requester is, and then it actually communicates. It sends the packet out as if it came from that guy. And then once it gets the response back, it knows, once it opens the packet, okay, who was the original sender within my LAN? Okay, this web server. Okay, let me forward this packet to this guy. So it does something called network address translation. Anyways, so internet gateway. So this router, essentially all the, this is what looks at the rules. Where do I send the packet to? Okay. So it will send it to, public subnet, private subnet. So we have two subnets here. All the database servers are sitting here, web servers are sitting here. And these guys have, look at the private subnet IP range, 10.0.1.0/24. I'll explain what it is. And then these guys have a different IP range, 10.0.0.0/24. Okay. So yeah, I'm gonna show you something very simple. There is a website called, I like this website, CIDR.xyz. Okay. Do you know what the CIDR stands for? You guys know about IPv4. Okay. So this is your typical IP address. IPv4 address is a number up to 255 dot, a number up to 255 dot, number up to 255 dot, another 255, right? So this is my local IP. So this is my IPv4 address. Take a look at this one here. Oops. Take a look at this one, 192.168.1.239. So 192.168 is a local IP address. There are a couple of local IP address ranges. One is 192.168, the other one is 10.0. Okay, so these are called local IP address. This is my local IP, but what's my real IP? What's my public IP? What's my IP? This is my outside IP. So if you need to connect to it, if you need to connect to me, if I spin a web server on my, in my network, if you want to come and access it, this is the public IP. This is the IP that you need to use it. Okay. But my router says that this is my IP address. Well, this is my local IP. This is within my LAN, local area network. Okay. But when I need internet, it does that network address translation. It actually translates it at the last gate. Okay. And this is my public IP. So this is IPv4 address, right? So what I wanted to show you is the CIDR.xyz. Well, this is classless interdomain routing, okay, or routing. So that's what CIDR stands for. So what it means is, essentially, within this 32 bits, so why do I have this number up to 255, number up to 255 is because we have 8 bits. So we have 4 octets here, 4 times 8, 32, right? So we have 8 bits here. So total 32 bits. That is how you will get the number up to 255, 0 to 255, right? So what's this number here? Say here. How do I get this one? 0 times 2 to the power of 0. Is it? No, sorry. 0 times 2 to the power of 1. 1 times 2 to the power of 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like that. You understand? So 2, 4, 8, 16, 32, 64, 128, 256. Okay. So if I want 255 here, what happens is, look at it, all of them becoming 1, because 1 times 2 to the power of 1 times 2 to the power of 1 plus 2 to the power of 2, 1 times 2 to the power of 2, etc. So you get that. You might have learned this in your bachelor's or master's. Okay. Anyways, the point I wanted to mention here is that classless interdomain routing, right? So here in your subnet, you wanted to say that, hey, how many of 32 bits, how many bits are used for the actual routing or subnetting? How many bits are actually allocated for the IP addresses alone? Meaning, how many IP addresses can I get actually? So let's say I'm taking this local area network 10.0.0. Let's say O/16. So what I'm saying here is that, hey, this is my IP range. I started with 10.0.0.0, and then /16 is what I'm saying, meaning 16 bits are used for routing, and the remaining 16 bits are used for the real IP addresses. So I can get up to 65,536 IP addresses. Okay. Because you have the complete 255 and another 255. Now let's say if I say that /8, okay, in this case, what happens is only 8 bits are used for routing, and the remaining 24 bits are used for your IP addresses. And then you will get up to 16,777,216 IP addresses. So if you go with this, they call it range, IP range /8 IP range, then you will get up to 16 million IP addresses. Okay. So when you create, why am I saying all of this? Well, when you create new VPC, you have to specify what IP range do you want to use it? What is your CIDR range? CIDR, they call CIDR range. Okay. So what would be your CIDR range? Well, I want to use this 10.0.0.0, and then Amazon allows only up to /16. It does not allow more than that, meaning number cannot be less than 16. So within a VPC, you can only have these many IP addresses, meaning you can only have these many resources. Does it make sense? Amazon does not allow bigger than /16 CIDR range. So if you want /8, Amazon does not support that VPC. So I can't imagine you need, any organization needing more than that within a VPC. Of course, you could have, definitely you could have resources more than this, but you can create your own VPCs. That's where you can logically break it down. You have your sandbox VPC, you have your QA VPC, you have your non-prod VPC, and you have your prod VPC. So you have, everybody having a separate VPC, and everybody getting up to 65,000 IP addresses. Does that make sense? Okay. So let's go ahead and create, without delay, let's go ahead and create our own VPC. But the whole networking concepts and, this whole CIDR, I would say I'm not the best guy to explain it. My explanation was average, probably. I would recommend, reading something or watching something else online, because that's it's not my subject area. Okay.
Venkat,
yes.
I have a question. So here it means like this VPN is, able to connect 65,536 IP addresses, right?
No, it means that if you create a network with this CIDR range, you can have up to these many IP addresses available for you, and you can use one for, meaning if you want to use this CIDR range for your public subnet, for example, that's a wrong way to put it. Okay, I'm saying this is for the entire VPC, right? So within your VPC, these many IP addresses available. Now you break your VPC into multiple subnets. This is a bigger bigger pool, right? You have these many pool of IP addresses is what I'm saying, ranging from, this is your first IP, 10.0.0.1, all the way until 10.0.255.254. Everything in between, you have the 65,536 IP addresses. So within that, so let me take a notepad. So let's strategize here, okay? So let's go ahead and create a VPC. So our VP, Uma, first of all, does it make sense?
Yeah, yes.
And it will make more sense in exactly 5 minutes, okay? So let's go ahead and create a VPC. And my IP, my CIDR range is 10.0.0.0/16. This is for my entire VPC. I cannot go anything lower number than 16 because Amazon does not allow me to do that. Okay. So now within VPC, let's logically break it. Let's say, let's create two subnets. One is public subnet. I call this as public subnet because these guys need to take requests from internet. And I'll create one more called private subnet. I'm calling them as public subnet and private subnet. Okay, I'm just muting people. Okay, so now this is a broader 65,000 IP addresses. Now I'm going to break them into multiple subnets. Now let's say I want to keep my public subnet CIDR range is 10.0. Again, look at this one, my first IP. I will get all the IP addresses from the first IP is 10.0.0.1 all the way until 10.0.255. In between, all of them together, you have 65,000 IP addresses, right? So what I'm doing is 10.0.1.0/24. Okay, let me tell you what I'm saying here. 10.0. Let's say 1.0/24. When I say /24, what does it mean? I'm using 24 bits for the network routing itself, and I will be left with only 8 bits for my IP addresses. So you have up to 256 IP addresses. So I'm creating 10.0.1.0 this IP addresses. So everybody will have a IP addresses something like 10.0.1.1, 10.0.1.2, 10.0.1.3, 10.0.1.4, like that, all the way until 10.0.1.254, all the way. So these are the public subnet IP addresses. So meaning 10.0.1.1 all the way until 10.0.1.254. Okay, this is kind of a range. Now let's go to private subnet. So does it make sense? Out of the 65,000 IP addresses that can be created within my VPC, I'm using about 256. Actually, Amazon, out of 256, Amazon will keep 5 of them, 5 IP addresses for its internal purposes, internally for subnetting and other details. Okay, I'll show you. So you will have only 251 IPs available. So for my needs, for my use cases, or for my company, 251 publics in public subnet is enough. So I created a sub range here. So if 256 is not enough, then I can go up to /22. Then I'll get 1,000. Or I can go up to 21. Then I'll get 2,048. Or 20. When I say 20, what it means is it's using 20 bits. It's using 20 bits for the network routing, and the remaining ones are for the IP addresses. Make sense? So this is my public subnet. And now in my private subnet, I'll use a different IP addresses, 10.0.2.0/24. So 10.0.2.0/24, another 256. I got it. But these IPs start from 10.0.2.1 all the way until 10.0.2.254. So all of my private subnet resources, like my databases, right? Their IPs will be like 10.0.2.1, 10.0.2.2, 10.0.2.3, etc. My database IP addresses will be like that. But my web server IP addresses are like 10.0.1.1, 10.0.1.2, etc. That's how they will be. So this is how I'm going to define it. Does it make sense before I go ahead and create it? This is like we designed it. We designed what we wanted to do. This is our 2 subnets, but there are a lot more. You can go up to, I think, another 254. Totally, you can have up to 255 subnets, right? Because you have 10.0.1.0, 2.0, 3.0, 4.0, all the way up to 255. Does that make sense?
Yes, Venkat. Yeah.
Okay.
Now, Venkat,
Yes.
you said Amazon would hold up 5 of those, right?
Yes.
It hold up from public subnet 5 and private subnet 5, or just
You got
5
it.
altogether?
No, you got it. No. For each subnet, each CIDR range, it holds 5.
Okay.
So from this one, out of you, all 256 will not be available for you to use. Only 251 will be available. I'll show you, where it shows. Make sense?
Yep.
So 10.0.2.1 all the way until 10.0.2.254. That's my, okay. Now with this design, without delay, let's go ahead and get started. So before we start creating our own VPC, I wanted to show you something. All along, you created a lot of web servers, database servers, all of that, right? So you have been playing with VPC without knowing. So let me show you what I mean by that. Go here and within your network. Where is your network guy? Yep, network and content delivery. And you have this VPC here, right? I'll show you. So this is your VPC dashboard. So number of VPCs is 1. I'm in Ohio region, and this is the default. Okay, I know I named it as a default, but this is what, this is your VPC ID, and this is your, IPv4 CIDR. See this one, /16, 172.31.0.0/16. That's what you did not create this. When you signed up for AWS account, it created for you. A default VPC gets created automatically for you. Okay, and then for each for each availability zone within your region, it creates multiple subnets. It creates 1 subnet for each availability zone. So we have 2A, 2B, 2C, if I'm not wrong. Yeah, 2A, 2B, 2C, 3 availability zone. It created 3 subnets. Of course, you can create multiple subnets within the same availability zone. You can, within 2A itself, you can create several subnets, no problem. But 1 subnet cannot span multiple availability zones. I want you to know that. It's a popular question in your exam, and also it's he tries to trick you with the same information. And this is where all the route tables are. By default, when you created your default VPC, when Amazon created your default VPC, it created a route table. Okay, let's take a look at the route table, the routes. So these are the 2 routes that it automatically created it. So what it's saying is the destination 172.31.0.0/16 IP range. This is your VPC CIDR range. So VPC CIDR range, your target is local, meaning you can talk to all the resources within VPC. They can talk to each other is what it means. Okay, but take a look at this one. These guys can talk to everyone through internet gateway. So every request out, it goes through the internet gateway. This is your internet gateway. So internet gateway has been automatically created. You did not create it. It automatically created it and associated with your VPC. Okay. So before I talk about other components, so one thing I want you to know, you are going to do this at least 5 times, and you will be doing it today. Okay. After I do it, so I'll make sure you get comfortable. So do not panic. Okay. So let's go to VPC here. Click on your VPCs, and this is the default VPC as I told you. Let's go ahead and create a VPC. Okay. I'll say my custom VPC. And then this is my name tag, custom VPC. See this one? A VPC is an isolated portion of the AWS cloud populated by AWS objects such as EC2 instances. You must specify an IPv4 address range for your VPC. So your IPv4 CIDR block. So what did we define? We said, hey, I need this kind of private IP 10.0.0.0/16. Okay. And then this is for my IPv4. Well, within your VPC, you can have the combination of both IPv4 and IPv6. You can mention IPv6 CIDR block. The only thing is you cannot, if you have some IPv6 CIDR, you can bring your own, or you can have Amazon create it. So for our, as a first step, I would say, let's not worry about IPv6 at all. So let's only worry about IPv4. So this is my IPv4 IP range, and I'm creating a brand new VPC and saying that this is how I want my IP addresses. So I'm defining what kind of IP addresses. Again, these are private IPs, by the way, right? So your tenancy, obviously select default. Please do not select dedicated. It will be extremely expensive. Okay. So, oh, by the way, by creating a VPC itself, they don't charge you. There's no charge just for the, creating a logical entity and creating your subnets and creating your subnets or route tables, any of that, no charge. It's like, but when you start creating your instances, that's when you'll get charged. Okay. So go ahead and create a VPC.
Hey, Venkat?
Yes.
So when you're saying these are that range that you have entered, where private IPs means outside, they can be existing outside.
These 10.0 stuff, it's a dedicated for private, and they do not exist outside. No.
Okay.
Okay. Like how you cannot have this 192.168. See here, this one.
Yeah.
This is another private IP addresses. Okay. So yeah, this is my custom VPC. So let's go take a look at it. As soon as a VPC got created, okay. So this one, a route table has already been created. A default route table has been created. A default network ACL has been created. I'll talk about this towards the end. Don't worry about it. And okay, so let's go ahead and take a look at what's been created with this VPC. Well, are there any subnets created? Nope. There are 3 subnets. These 3 subnets were created. These 3 belong to my default VPC. Okay. So one recommendation I want to give you is that please do not your default VPC. Please leave it like that. Okay. After you are very comfortable, you can delete it, because once you delete it, if you make a mistake, then there's no other option. Actually, you'll have to contact AWS customer service. So leave the default VPC. So this is your VPCs, and the subnets did not get created when you created a VPC. Let's take a look at the route tables.
So Venkat, default VPC set, is it comes when you create an account, it comes automatically with it? Or?
You got it. Yes. Yep. So you don't have to do anything. It gets created automatically. Okay. So route tables. So Looks like it created a new route table. Take a look at what it belongs to. So there is one route table that got created and attached to your default VPC when you created your account. But just now, when we created VPC, it created a new route table and associated to this VPC. Take a look at your routes. Okay, see this one? By default, the rule says that, yes, you can talk to anyone within your VPC CIDR range. Target is local, meaning it's you can talk internally only. So at this point, if you spin up a new EC2 instance and inside this VPC, there is no internet connection. I want you to understand that. At this point, if you spin a new EC2 instance, that guy will not have internet connection. You will not be able to connect to that EC2 instance even if you open SH port. It doesn't matter. Open any port to the world. You will not be able to connect to it because there is no internet connectivity to your VPC. Does it make sense?
It does, Venkat, but default, it is already pointing to default, and default has an internet gateway, right?
Okay. So default, yes. Default VPC has internet gateway attached to it. Why? There's no magic there. It created an internet gateway and attached it or associated with your default VPC. So if you create a new web server, new EC2 instance in a default VPC, yes, you will have internet connection, meaning you will be able to connect to that, and you'll also be able to go out and fetch from internet, within your EC2 instance. But if you spin a new EC2 instance in your new custom VPC, you will not be able to. What I mean by that? Well, I'll remind you. Go to EC2, click on your launch instance, Amazon Linux AMI, general purpose. This is all good. And now pay close attention. I know all along we have been doing next, but now let's try to understand it. Number of instances, 1. Purchasing option, well, that's okay. My focus here is this one. Kind of these three area. Network. So it is saying default, but now all along we only had one VPC. Now we have 2 VPCs. Now I want my new web server to be created in this new custom VPC. And it's saying that there are no subnets in this one. Well, okay. A subnet is required when launching into a VPC. So at this point, we only created VPC. We did not create any subnets. Of course, we will do that as a next step. But my point is, if I spin this EC2 instance in this custom VPC that we just created it will not have any internet connection. You will not be able to even access into that, SH into that. And then of course it will even somehow, if you're inside the network and then somehow logged in, and then if you try to go out and get the operating system patches, sudo yum updates and all, they will not work. Does that make sense, guys? So let's do 2 things. One is, so what did we just do? We just created a VPC and we provided a CIDR range to that. Okay. We provided a CIDR range of 10.0.0.0/16. Okay. We'll get about 65,000 IPs. Sure. And then we did not create any subnets yet. Let's go ahead and create a couple of subnets as per our design. Our design says that we need 2 subnets at this point. One is public subnet. This is the kind of CIDR range, because we wanted to put all web servers in 10.0.1.1 series, and we want to put all the database servers in 10.0.2 series. Okay, let's go ahead and do that. And we can do that in the same availability zone also. We can do that in the same availability zone, or we can put this guy in one availability zone and put another guy in another availability zone. We can do that just for fun. So let's go ahead and create a subnet.
So
You call
when
this.
can same IP address range be in multiple subnets?
Can you say that again?
Can the same IP like range be in the more than one subnet?
No,
No.
no, because your CIDR range has to be different.
Different. Okay.
Yep. So this is my public subnet. I'm creating a public subnet, and then within VPC, I want a new subnet to be created in my custom VPC. And when you create a subnet, you must select what availability zone it is going to be in. Okay. One availability zone can have several subnets, but one subnet cannot span multiple availability zones, because subnet is range of IPs, and you're logically grouping at the network level. And obviously, one similar kind of resources, meaning all the web servers will be in one subnet, all the database servers will be in subnet. Okay. So let me go ahead and put public subnet in 2A. Okay. And this is your VPC CIDR. So up to /16. Now this is a subset. Within that subset, sorry, this is a VPC CIDR. So this is a superset. So within that, select a specific range of IPs into this subnet. So my range is 10.1.0/24, meaning 256 IP addresses, but out of 256, Amazon uses 5, and then we will get 251. Let's go ahead and create it. I created a new subnet. I created a public subnet in, this is the IP range, IP CIDR 10.0.1.0, and see this one, available IPv4 addresses, 251 IPv4, because 256 minus 5. Let's go ahead and create a separate subnet, private subnet. And then in my custom VPC, availability zone, I'll go ahead and create in a different availability zone. And then 10.0.2.0, is it what we designed? Yep, /24. What happens if I do a 1? See that? CIDR address overlaps with existing subnet CIDR. Is this not the question you asked, Murali?
Yes, sir.
So let's go to 10.0.2.0/24. Let's go and create it. So we created our own custom VPC, and we created 2 subnets. One is public. We called it public subnet. Okay. We called it public subnet. What is our intention? We wanted to keep all the web servers in public subnet, and they can have internet, and they can actually take the request from outside our VPC. That's why we called it public subnet, and they can have internet. But private subnet guys, no, they cannot have internet, and they do not take requests from outside. That is why they call it private. But we did not do anything about it. At this point, they both are same. Just because you named it as public and private, they don't automatically become public and private. There's no magic. You have to make it happen. We'll see how we'll make it happen. Okay. So at this point, we created 2 subnets. Now, the first thing I want to do is, at this point, no internet, right? If I create a new web server in either of the subnets, let's go ahead and put it in a public subnet, you'll not be able to connect to it, because for this VPC, there is no internet connection. So how do you get internet connection? Well, internet gateway. There is something called internet gateway. So you have to create a new internet gateway and attach to the VPC. One VPC can have only one internet gateway. That's all. So I'll create my custom internet gateway. An internet gateway is a virtual router that connects a VPC to the internet. to create a new internet gateway specified. Okay. So this is a virtual router that connects a VPC to the internet. It's like this in this diagram. See here, its internet gateway sits at the VPC level, and pretty much it acts as a proxy for all outgoing and incoming traffic from and to internet. This is internet gateway. So I created a new internet gateway. At this point, the status is detached, meaning the equipment is ready. Internet gateway got created, but it's not associated with any VPC. So let's go ahead and associate it. Actions, attach to VPC, and I'm only seeing custom VPC. I'm not seeing the default VPC because default VPC has already been attached. Okay, so one VPC will only have one internet gateway, and this is how we can attach it. Well, if you want to use a CLI, you can use this command. That's what that's what it means. Well, let's go ahead and attach it. Okay, now internet gateway has been attached to the VPC. Now, if you spin a new instance, okay, it will have internet, but not quite yet. So we created an internet gateway and then attached to the VPC, but we did not adjust the route logic yet. Okay, the route table has a routes, meaning the rules. The rule says that, let's go take a look at the route table, right? The route table. Okay, first of all, let's go take a, hey, let me ask this question. Where are the resources sitting? Resources will sit within a subnet. Agree? Resources will sit within a subnet. And this subnet will have your route table attached. Let's go take a look at it. So let's go take a look at this route table. So this is for the default VPC, and let's not worry about the default VPC. We are not playing with that. This is for the custom VPC. So by default, when you created your VPC, it created a default route table, and the default route is you can talk to anyone within this. Okay. So this one, we call it default route table. Okay. I'll name that way. Default route table for our custom VPC. This is a default route table for custom VPC. Okay. And now if you look at your subnet associations, at this point, we have two subnets, and both the subnets have not been associated with a route table. Meaning there are no rules at this point. Okay, we have to do that. So by default, what we can do is the following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So this is the default route for the custom VPC, right? So let's take a look at this one. Is this a main route table? Yes. So this is acting as a main route table for this custom VPC because there is only one route table at this point, and the rule is, the route says there is only one rule out there. It can talk to anyone, any IPs within this range, meaning it can talk to anyone within the VPC. It cannot talk to anyone outside. That's what it says. Okay, we just created an internet gateway attached to the VPC, but still there's no route out there. We need to provide a route. Okay, but I don't want to mess with this main route table. Okay, I don't want to mess with the main route table. The reason I don't want to give internet connection through the main route table is because this main route table, when I create a new subnet, by default, they get associated with the main route table. So I want my main route table to be as secure as possible. So if I want to give internet connection to someone, I want to be very explicit. and I want to be very cognizant of it. Okay, so I can call it a default, or even actually I can call it as a main route table. Main route table for my custom VPC. Okay, now this is my main route table. At this point, both the subnets are associated with this main route table, because there is no explicit association, but this route table happens to be the main route table for this VPC. That is why these subnets are automatically assigned to that. The default rule at this point is everybody can talk to anyone within the VPC. So that means you cannot talk to outside yet, right? So what I will do is I'll create a new route table. I will call this one as a public route table. Public route table for our custom VPC. You can, when you create a route table, you'll have to mention, who are you creating for? Are you creating for your default VPC or custom VPC? Well, I'm creating for custom VPC. Sure. Now I have got public separate route table. Okay, but the default rule is you can talk to anyone locally. But no, I want to edit the rules. Now, are you guys following it? I left this main route table as is. I do not want to touch that. I want my main route table to be as secure as possible, but I created, rather than messing with the main route table, I created a brand new route table. I call it a public route table. Now I'm changing the rules. Now I'm going to add a new route saying that now o.o.o/o, meaning everyone, anyone in the world, right? So internet gateway. So every request must go through the internet gateway. So essentially, this is how I'm giving internet access through this rule. So I added a new rule to get or to route the traffic through internet gateway. To route the traffic through internet gateway. Internet gateway is acting as a gateway, between the resources within your VPC and the outside world, outside public internet. So I created a route, and now public route. Okay, I have a rule to go out to the internet gateway. Now what do I do? By default, let's go to take a look at the subnet associations. At this point, these two subnets are associated with the main route table because there is no explicit association. What I will do is I want to assign my public subnet. I want to associate this newly created route table to my public subnet. I'll do that. So I want to associate my public guy to this. So now take a look at. So my public subnet is associated with this public route table. Public route table has a route out to the internet through internet gateway. But if I go to the main route table, does not have a route out to internet. It only has one route, which is, within the VPC side. Does it make sense? And now take a look at the subnet association for this guy. Well, there is private subnet is associated with the main, and public guy is associated with my public route table. So this is how you're making your public subnet as public, because you attached it, you wrote a new route in your route table and gave a route out to internet through internet gateway. Now, if you spin up any new web server in your public subnet, you will automatically get internet connection. So one other thing that I wanted to, okay, so far, let me stop here. Any questions so far? Is it all Greek and Latin, or is it Am I making sense?
Making sense.
Okay. So far, I mean, we have no connectivity between those two subnets, right?
So 1 second. Okay, so can you ask me again?
So there is no connectivity between the subnets, right? So far.
Both the subnets are in a single VPC, and the route says that there is a route here says that anybody can talk to anyone as long as you are within the VPC. Right? This is your VPC side.
Oh, this is okay. VPC level, okay, not at the subnet.
So this one you can't change it. Meaning the resources within VPC can talk to each other.
Okay. Yeah.
Okay, but this guy has public internet access through internet gateway, because see this one, your destination, anyone except anyone except this guy, okay, you go through internet gateway, and internet gateway is acting as a proxy to send the traffic out, or in fact to let the traffic in too. But you look at your main route table, has only one rule. If I attach this guy also to internet gateway, then everyone, all the subnets associated with this main route table will also have internet connection magically. Does that make sense?
Yes.
Any other questions?
So Venkat, if you
Yes.
open up that last slide of your PowerPoint,
Mm-hmm.
so in this case, whatever comes from public internet all the way reaching to the router is part of the public subnet. Is that what I'm trying to understand? And from that
Mm-hmm.
point onwards, everything become a private.
No.
No.
Let me explain this. See, this is a public. This is public internet, right?
Yes.
So when someone is trying to talk to, when a guy here, let's say a web server here, okay, so what happens is it always comes through internet gateway. Every resource here within this VPC must come through internet gateway. Every packet from outside or every packet to outside. Does it make sense? Internet gateway is acting as a front gate or proxy pretty much.
Yes.
For the entire VPC, right?
Mm-hmm.
After this, it will give the packet out to the router. There is a virtual router, right?
Okay, correct now.
Okay.
And router
So
will define where to go.
This guy, the router depends on the routing table rules. That is why you are defining. So you created your routing, your route tables, right? So you created this route table. Look at this one. You created this route table and attached to this subnet, and you created this route table attached to this one. In fact, it's the same main route table. Okay, don't worry about this NAT gateway here. Okay, so we only have this one at this point. So your main route table, okay, your main route table only has this one 10.0.0.0/16. Okay, target is local attached to the private subnet. But your public route table, I called it as a public route table, has 10.0.0.0/16 to local, meaning you can talk to anyone within VPC, but you can talk to anyone through internet gateway. So what it means is when someone is trying to talk to this guy, right? Then this guy will decide, okay, who are you trying to talk to? Are you trying to talk to, sorry, let's say web server is trying to go out, right? So if I'm trying to update my web server, like a sudo yum updates, okay, at that time, so are you trying to talk to, who are you trying to talk to? Well, I'm trying to talk to somebody outside of my VPC. Then what it does is it will look at the route table, it will look at your route logic and then see, okay, this guy is outside of my VPC. So what does my route say? Okay, anyone within the VPC, send it to local, meaning you can talk. Okay, you don't need to go through anyone. Okay, so but outside of this VPC, if I want to talk to someone, let's say Google, I did call google.com. Okay, then it will say, okay, this, it comes to this guy. Okay, let me send it to my internet gateway, and the internet gateway will do something called network address translation and then send it out to the Google. So I took a scenario of web server trying to talk out. Now let's talk about Ketan sitting in his home trying to access a website that is sitting inside this web server. It goes through the internet gateway. Again, look at the route table. Okay, and it's coming from internet gateway, and then you are trying to access somebody here. It will look at it and then find out where that guy is, and then it will forward it to it.
Yep, got it. So
Okay.
basically, indirectly, we are doing that over maybe web servers in one subnet and database in another subnet, and these two subnet will talk internally with private network, but only we are able to access from public internet. We are only able to access public, just the public subnets only or web servers only. That's it.
Exactly.
Got it.
So only web servers can go out of your VPC and talk to someone outside of it through internet gateway. Why is that so? Because it's not because of magic. I want you to understand, not because we named public. No, it can be anything. It can be Ketan subnet. Because you attached internet gateway, you created a new rule here saying that, see this one, anyone outside of your VPC must go through internet gateway. So you attached internet gateway, created a new route, and you attached that route table to your public subnet. If I swap this one, if I go here and then say, if I swap this one, this is my main route table, right? So if I subnet association, there you go. If I do I'm in main route table, you can only talk to people within your VPC. If I go associate,
Not on the main one, right? Venkat, you have to do on the secondary one, right?
Yeah. What I'm saying is that if I associate both of them like this, now both of them don't have internet. My point is, I have two subnets, both private and public subnets. I have associated to the main route table, and main route table only has one route, which is everybody can talk to everybody only internally. There is no internet gateway here. So both the subnets now, all the resources lose internet all of a sudden. Does it make sense? Because both the subnets are associated to the main route table and nobody is in the public route table.
Yep, it does. Now, 100%.
Now,
I got it.
edit subnet association. I'm moving it back. Now take a look at it. Now, your public guy, your public subnet is associated with the public route table, which has a route out to internet gateway. And then you have your private subnet is associated with your main route table, which does not have route out to internet gateway. Does it make sense, guys? In fact, yes.
Yeah, so every time do we need to create it two route tables? One is for main and one is for public. I mean, we are creating these route tables for this any VPC, custom VPC. Every time do we need to go with two?
Okay, that's a good question, Kalyan, right?
Yeah.
So that's a good question. So let's think about it. It's all up to us. So we created a custom VPC. First of all, how many subnets do you want to have? In fact, do you want to have public and private subnets? Meaning, or do you want want to give internet access to every single resource within your VPC? If so, attach your internet gateway to your main route table itself. Don't worry, just delete this guy. Okay, attach directly here. Okay, and then all of your subnets will be associated with this guy, and whatever the rules that you have within this route table will be applied. If one of the rules is attaching internet gateway to that or associating internet gateway to that, then they will have internet. Otherwise they will not have internet. So all of your subnets will either have internet or no internet. You can't have both of them, right? Does it make sense? Because you cannot associate multiple route tables to one subnet. You can associate one. Am I making sense? One subnet can only have one route table association.
So one subnet can only have one route table, right? You are saying. That's correct. So here two route tables are there. So
Yep.
One is public and one we make it private.
Yep.
So I wanna create one more route table. Can I include both public and private, because we already assigned those two things here? So can I include both in another route table?
So what's your objective?
No, just I mean, it's a random question. I don't know.
That's
much
okay.
about,
That's fair. So then don't worry about it. So can you ask again?
I got it. What you are saying. Anyway, suppose anyway, when I'm trying to, in my VPC, I do have like database servers. I don't want to expose to others, so I will always put them as a private. So
sure.
I don't, but I wanna expose my web services, so I will make them to available to public.
Sure.
But for some users, I wanna give both of them.
Both of them meaning what?
Database also. I wanna give the access to them to access the databases as well.
Sorry. So here, what we are trying to do is that whether they will have the route out to internet or not, that's what we are discussing, right?
Okay, sorry. Actually, this routing concept a bit.
Yeah.
Okay, I got it. Okay, thank you.
Okay. Does it make sense?
Yeah, it makes sense.
See, this one, the main route table is associated with this subnet. Or I'll put it this way. Unfortunately, this 78F4. So there's no name here. This is a private subnet here, 78F4. So the private subnet is associated with this main route, which does not have any route to internet. But the public subnet is associated with this public route, which happens to have internet gateway route out, essentially. Okay, so one subnet cannot be associated with more than one route table. Of course, you can create one route table. Route table is nothing but a simple logical entity that has multiple rules in it. It's like security group. That's all. It's you have all the rules. You can go attach to as many subnets as possible, but one subnet can have only one route table association at any time. Okay, so now with this setting, right, what we will do is we will go ahead and install. We'll go ahead and provision new web server and put it in this public, public subnet. Okay, and then we'll see if it has internet connection. And then, sorry, not this one. This one, the next, this guy, public subnet. And then we will create one more instance in our private subnet. And then let's try connecting to both of them, and how we can connect to it, etc., etc. At this point, if I spin up a new EC2 instance and put it into my private subnet, I will not be able to connect because it does not have any internet connection. Because it does not have a route to internet gateway. Okay, Can I go ahead and proceed, or you guys have any questions, or you want to, is it too much? Let me go ahead and launch an instance if everyone is okay. Okay, let's pay attention here. Network is my not default, my custom VPC. And now, where do you want to put it? Where do you want to create this instance? Do you want to do it in public instance, public subnet or private subnet? Your public subnet is inside this 2A availability zone, and your private subnet is in 2B. So where do you want to put it? Well, I'm planning on provisioning a web servers. So I'll put it in public subnet. And then auto assign public IP. Do you want?
Venkat.
Yes.
Okay, so when you select network and when you do the custom VPC, based on what is available in custom VPC, subnet is displayed, right?
Exactly. If I put it as a default here, right, I will
Then
get
I will
all
have
those
a
three.
free
Remember, there are three
Yep,
subnets that automatically created.
Yep, got it.
When you signed up with AWS, it automatically created a VPC, and as part of that, they automatically created one per availability zone, one subnet per availability zone. They automatically created for you.
Yep,
To make your, that is why all along we didn't do any of this. Without knowing, you've been playing with that. It's just, I've been doing next. I never actually stopped here and tried to explain it, what this one is. Because I'm waiting for this moment, right?
Yes.
So custom VPC, and then now subnet, yes, public subnet. See this one, 251 IP addresses available. Now, if I take this instance and then create a new, when I try to create a new one, next time it will say that 250 IP addresses available. Auto assign public IP. Do you want the public IP? Well, use subnet setting. By default, subnet is saying that disable it, but I want to enable it. You know what this one is? Public IP. I want public IP to be assigned to this guy. Please assign it so that I will be able to access it from outside, because this is a web server and I need to be able to access my web server from outside of VPC, from a regular public internet. So I need a public IP, please. That's what I'm asking. Does it make sense? By default, it's disabled, but I'm saying it's enabled. I'm sorry. So give me public IP is what I'm saying. That's all. So everything else, I think this is all pretty straightforward. Add storage. I'll call this guy as my web server 1, let's say, in case we happen to create it. Okay, security group. Did you realize this one? Security groups cannot span, excuse me, security groups cannot span VPCs. In fact, you have some security groups in your default VPC. We've been playing with it, but they will not be visible here because security groups are per VPC. So let's go ahead and create a new new security group. I'll call it web servers security group. And then port 22, sure, I open it to anywhere. And then I'll create another rule, HTTP, port 80. I want everybody review and launch. Okay, and launch. And this time I have this key pair, but if you don't have a key pair, I highly recommend create a new key pair, because we need this key pair. I will tell you why, but I recommend, creating a new key pair and then save it. Okay. There, I put it in custom VPC key pair. I have it. I acknowledge it. Launch instances. Okay, my web server is coming up in US East 2A. And in my public subnets, let's take a look at this dashboard more clearly now. Your instance ID, state is blah. Okay, your subnet. Now take a look at this one. This is your subnet. Your instance is getting created in this subnet. That's called public subnet. Okay. Go click on this one and it will automatically take you to your subnet place. This is your public subnet. Okay. And your public subnet, this is your public subnet. Let's take a look at what route table it is associated with it. Your public subnet is associated with this public RT-custom VPC. And what are the rules inside the route table? Well, one is local to your VPC, and the other one is to internet gateway. This line of code, this line here is what making it possible for web servers having internet access. Just this line here. Make sense? Now, let me try connecting to it. Okay, I'm able to connect to it. That's pretty good. And then sudo yum update. And no packages marked for update, so everything is good. Sudo yum install httpd. Yes, please. So it has internet connection, nicely went out to the public internet, you know, grabbed the httpd and then installed it. Everything is good and we are able to connect to it. Now what I will do is, just to show you, I'll go to this route table. I'll go to this route table, go to public route table, go to routes, edit routes. I will take out this guy. I will take this guy out and then save routes. Okay. What did I do just now? I removed internet connection to that subnet pretty much. Okay. Now it still has public IP. Let's go try to connect to it. Well, you can't do it. You can't do it. It will not work. It's nothing to do with security groups. The security groups are closest to your EC2 instances, but I actually anchored off internet connection to the subnet at the much broader level, to the entire subnet, not just this instance. All the instances within subnet, they will lose internet connection now. They cannot go out, or someone else cannot come in. Does it make sense? Now I will add it. Let's go back, edit routes, add new route. Internet gateway. Let's associate internet gateway to this guy. And then now let's try connect to it. There you go. Make sense? So I have HTTPD. I'll kick off service HTTPD. Start. Sudo service HTTPD. Started it. And then I'll do nano. Is nano or VI, whatever. I'm just creating a simple HTML. Hello from web server from public subnet. Hello from web server. Okay. So now I have this public IP. Copy it. Try going there. Hello from web server from public subnet. Hello. From web server from public subnet. That's probably grammatically wrong, but not a big deal. Anyway, so you got that? So that's about the public subnet. Now what we'll do is we will spin another instance into private subnet, and then I'll show you. let's go ahead and spin up a new EC2 instance. And this one I will call it database. I'll call it as a database server. Okay, number of instances 1, network in my custom VPC, but this time not in public subnet, but private subnet. Okay, private subnet. And then, sure, 251 IP addresses. See that? 251, 256 minus 5, 251, because this is the first one within the subnet. Okay, we had a web server spun up in a different subnet that's in public subnet. This one I will call it DB server. And my security group, I'll create a new security group. DB server, I'll say port 22, anyone, sure. And then MySQL 3306 to anywhere, it doesn't matter really what you put it, because there is no route out there. Custom VPC, key pair, sure. Okay, now I created second guy, the DB server 1 in US East 2B, because the subnet happens to be in US East 2B. See this one, subnet is in private subnet. Let's take a look at private subnet rules. Private subnet, this is a route table. And this guy has only one route here, which is only local route. It does not have route to internet gateway. So it does not have internet and you will not be able to connect to it. And of course, your public IP is not there anyway. So you can't do it. Connect. Of course, it says public IPs. You do not have a public IP associated it. Even if you bring up an elastic IP, you will not be able to connect to it. Okay. Elastic IP. So now the point is, but how will I be able to connect to it? This guy does not have internet connection. It can go out, or someone else from outside cannot come in. So now we are trying to go in or log into the DB server. We are not able to do it. Can anyone think of any idea? You know, it may not be straightforward, but
from route table we have to go there.
From route table, we put the route table very consciously, right?
Yes. So basically, from web server 1, we can call DB server now.
I like that idea, actually. Yes. Anyone else thought of that? So what he's saying is, these two are inside the same VPC, and the route table has a rule that anyone can talk to anyone within the VPC, the private route, this guy here, right? So what he's saying is, this guy has a public route, web server 1, because this guy has internet gateway attached. So log into web server 1, from web server 1, log into DB server. Right? Are you guys following? Everyone following?
Yes, Venkat.
Wonderful. Let me, where is my guy? Okay, let me connect to this web server 1 again, and let me see if that works. That's exactly what I'm logged into web server now. Okay. Now, what is my web server IP? Guys, are you looking at it? 10.0.1.147. So remember that 10.0.1. That's our strategy, right? I'll go back to our design here. See this one? Our public subnet, we gave 10.0.1.0/24. So this 147 has been assigned by Amazon, but take a look at this one, 10.0.1. That's our range. And the private DB server, 10.0.2.203. See that? 10.0.2. So it matches. So it's good. Now I'm in web server. Now I want to log into the DB server from web server. Okay. So how can I do it? Well, this is how you can do it. First of all, let me open that private key. The reason I asked you to keep that private key is because of this. So keep this private key. What I will do is I will store it. I mean this one, VI, my DB, my private key is fine. My private key dot PM, and then put that private key there, save it. This is my private key dot PM file now. Okay. I stored all the contents of the private key. Does it make sense what I did here? Anyone has any questions here? Earlier, I asked you to download that private key, right? I know I have it already, but if you don't have it, go download it. I mean, you have to download only there when you create new key pair. It gives you a chance only once. Okay. So I'll do a chmod 400, my private key .pm. Okay. I reduce the privileges. So, yep. This is good. Now, how do I log in? SSH ec2-user. So this is a Linux machine, right? I'm in a Linux machine of web server. Now I'm trying to talk to database server. SSH ec2-user at, what's the DB server IP address? 10.0.2.203. 10.0.2.203. Is that right? Yes, 10.0.2.203. Sorry, 203 space minus I, my private key. Hey, now I'm in 10.0.2.203, or you can go to ifconfig, and then it gives you the IP address of this Linux machine. 10.0.2.203. I'm in my database server. Wow. I stored my private key. I stored my private key in my web server. That's not correct way to do it. Okay. But this is a way to do that. This is definitely one way to do that. Rather, I'll show you later. You can use something called Bastion host, or they call it Gembox. So you can do that to, to connect to it. Anyways, so I'm in DB server. Yes, go ahead.
So even though, both the machines are within the range, the private or local, even then you need to use the private key connect.
Oh, of course, because the other one doesn't let you, right? It's all about, yeah, you have access to login. Okay, your SSH port is open. It doesn't mean that you can come without the password, right?
Okay.
Your private key is like a password, right? So yes, port is open. You have access to it. It doesn't mean you can come. The door is open. No, definitely not. Okay. So now don't get confused. Where are we right now? We are in DB server. Does DB server have internet access? Does DB server have internet access right now? No, because it is in private subnet, and private subnet has a main route table. Main route table has only one route, which is local route. It does not have route to internet gateway, so it does not have internet. How do I know that? Now, let's prove it. Sudo yum update. Okay, loaded plugins, extra suggestions. Okay, it's trying. There's no route. It goes to the router, and then router will look at the route table and then look at it. Okay, I don't have access. You are trying to go out. Okay, but I only see one route there, which is local, guys. But you are trying to go out of your VPC. I'm sorry, I don't see a route here. So I'll reject you. So it will get rejected. So no internet connection. One of the configured repositories failed and M doesn't have the cache, all of that. Yep, timeout. Timeout after these many milliseconds. You got it. So it's trying to go to HTTPT, Amazon Linux.us is to Amazon. Later, this is where it's trying to go and get it. But nope, it could not go out. Make sense? No internet. Well, it makes sense for not allowing the traffic from outside, but at least it needs to be able to, patch the operating system. It needs to be able to install the software like MySQL and all, right? It needs to be able to go out. It should not allow the traffic from outside. Absolutely. Makes sense. Okay. So you must not associate an internet gateway. Fair. Because this is a private subnet. There should not be a route out to internet. Very fair. But at least from outside, so once you attach to the internet gateway, it's two-way flow. Meaning outside guy can come in and inside guy can go out. Packet can go out and packet can come in, right? But at least this guy should have internet access to be able to do operating system patches, install the softwares, etc. So how can we do that? But I want to keep it private. I don't want to expose it to internet gateway, which is a two-way traffic. I do not want to allow that. How can I do that?
Is it where VPN comes into picture?
Hello, can you see that?
Can we use VPN? Is it where we use VPN?
No, VPN comes into picture when any of the resources within your VPC wants to talk to someone in your corporate network. That's when VPN comes into picture.
Okay.
We need private internet to connect to it somehow.
Not really. No, but there is another concept called network address translation, and Amazon or AWS makes this possible, this particular scenario. For resources within the private subnet, how can they access internet? There are two ways it provided. AWS provided this solution two ways. One is called NAT instance. One is called NAT, network address translation. NAT instance is one option. The other one is NAT gateway. So what you need to do is let's look at this guy closely. So this internet gateway is attached only to public subnet. How? Through this public route table, like with this route here. Okay. So only public subnet can go out through internet gateway. There is no exception there. But these database servers wants to somehow go out. Well, what they can do is they cannot go out through internet gateway directly because we don't want to give that access. Okay, we wanted to keep our database servers as secure as possible. But what you can do is these guys can go out to. What you do is you create something called NAT instance or NAT gateway. Okay, you create that in your subnet, in your public subnet. Sorry, you create that in your public subnet because public subnet have access to internet gateway. And then what you do is you give access to NAT gateway or NAT instance, meaning you are proxying it. You're putting one more proxy there. What this guy does is network address translation, NAT instance, right? What this guy does is when you make a request as a database server, when you go out there, what NAT instance does is it will translate the address. It will mask that, database server is actually calling you out. Rather, on behalf of you, it will go out to the internet, get the packets. On the way out, it will give you back. It does the network address translation. So on each packet, it will write something called the source destination check, they call it. Okay, so who is the source? Actually, where is it trying to go out? Destination. So essentially, you will have to create one more instance. A dedicated software will be installed on the TC2 instance. You have to put that in the public subnet, and you have to give a special route to that NAT instance, if that makes sense. Let me draw that if it doesn't make sense. So what I'm saying is that what I was saying is that, so you will create something called, let's start with the NAT instance. So you will create a NAT instance in your public subnet, okay? And then you provide a route from your database servers to your NAT instance, like that. So on this NAT instance, by virtue of being in public subnet, it will have access to the internet gateway. It will go out. So there is a special piece of software that's installed here. What it does is it will do the network address translation on behalf of you. It will go out. It will send that packet. Okay, it can be done. It can be done in one of two ways. One is NAT instance. The other one is NAT gateway. I will show you how. So at this point, we realized that the database servers do not have access to internet. Okay, how can I get internet access to my database servers who are inside private subnet? Well, I'll show you that. So let's go to EC2 instance. Okay, this time let's go to community AMIs and then search for NAT. Okay, see, there is an AMI, Amazon Machine Image out there. You can use the first one. This one, it comes with the software installed on it. Okay, it's a NAT related network address translation piece of software. And then essentially you're putting that in your custom VPC and put that NAT instance in your public subnet, guys. Okay, you have to put that in public subnet because the resources in the public subnet only have access to internet through internet gateway. And take a look at this 250 IP addresses now. It's not 251. That one has been taken by our web server, and we're putting an additional NAT instance right now there. Okay, add storage, and I'll call this guy as my NAT instance. Security group, well, use your web server security group, okay, because it's a public one. And then it is asking boot from general purpose SSD. Do you want me to boot from general purpose SSD, which gives much more IOPS because it needs higher IOPS? Do you want me to do it every single time? For every single one? No, just use make general purpose the boot volume for this instance only. Click on launch. Okay, and go ahead and. So what am I doing here? I'm provisioning a new specialty EC2 instance called NAT instance. Okay, from a community AMIs. There are some AMIs out there that can automatically do it. Amazon itself has one of them. That's what we selected. We put it in a simple T2 micro. Okay, but the biggest disadvantage of using this NAT instance is that it's a simple EC2 instance, it's not fault tolerant. If that VPC, if that EC2 instance is down, if that NAT instance is down, then all of our resources within our public subnet will lose internet connectivity, right? So that's why NAT instance is not a good way to go. Instead, Amazon has an answer for that in the form of NAT gateway. With the NAT gateway, we don't have to do anything. You just go create a NAT gateway and put it in your public subnet, and then magically, you'll have. Of course, you have to provide a route to NAT instance. Okay, so I created NAT instance, and then let's see if we have internet. Obviously, we will not have internet access yet. Oops. It's completely lost. Okay. So let me log into web server now. Now SSH EC2-user at 10.0.2. What's our DB IP? 10.0.2.203 -i. Very good. I'm in DB. Sudo yum update. I know it's going to fail. Why? We created NAT instance, right? So every single request will be proxied through NAT instance. How come my sudo yum request is not proxied through NAT instance? Any thoughts there?
Yeah, we have not given internet connection to it yet, right? We have not routed it, connect to router yet.
That's the right word, yes. So we have not routed. So our private subnet is attached to the main route table, right? So let's go to our private subnet. Let's attack this logically. So our DB server is inside private subnet. Let's go there. Private subnet is associated with this route table, and this guy has this route. So see this? Oh, it has only one route. So let's go change it. Route table. This is our main route table. And go routes. There is only one route out there. Let's add an additional route. Now what we will say is that every request going out must go through NAT instance. Click on instance here, and see, you can make anyone as a proxy, but these guys don't have the software to do that. The specialty network level software, the network address translation, that is there only on the NAT instance. That we did not do anything. It's just we took a community AMI and then spin up, right? So what we are saying is every single request out of VPC must go through NAT instance, and NAT instance will do the network address translation, okay, and then send it to the internet gateway. Save routes. Now it will, but even now it will not. I'll tell you why. There is an additional check we have to do. Okay, these are all EC2 instances, right? So by default, all the EC2 instances, when they go out, they will be by default, the source destination check will be enabled. When you do the network address translation, see our NAT instance EC2, this guy is acting, it's acting as a proxy. So it's acting as a proxy for all the internet traffic, right? So every packet coming from our private subnet, it's going through NAT instance. NAT instance will forward to, it will do a address translation, network address translation, natting. They call it natting. So it will do natting and then send it to internet gateway and then go there, right? So what happens here is that we have to disable only for NAT guys, NAT instance, we have to disable this change source destination check. Are you sure that you would like to disable source destination check for the NAT instance with the following? This we must disable the source destination check with your NAT instance, only for NAT instance, because this is not a regular EC2 instance to do the source and destination check. Though source destination check should not be done for this NAT instance because it is acting as a proxy, because that's what its job. Now we should be all set.
Okay.
Yes.
What is the source destination check?
So source destination check, essentially, when a packet goes out, see, when database server sends it wants to send a packet out to Google saying, give me something from Google, right? So it will send a network packet. And when it goes, the network packet goes there, NAT instance eventually send it to the internet gateway. So what they do is, who is the source and who is the destination? So they will update, okay, source is my database, okay? Source is my database, database server, wherever the request is originated from. My destination is Google, let's say. And this guy will update that. That's what exactly is natting means. So this guy will update that, saying that my source is, it will put it as itself, and then only it's masking it essentially. So it's faking that it's it was originally originated from database server, but it says that no, it's originated from me. Then only your network internet gateway will allow the traffic. Okay, say that okay, it came from me, but it will store that information. When I get the packet, actually it will not store here. It's stored in the packet itself, the network packet itself, that where is the final destination. On the way back, when I get the response back from Google, who do I have to send it? I'm being the middleman here. I get the packet out saying that I'm a database one. Okay, then I will change it, saying that I'll put my time, my impression on it, so that it will go out the door on the packet. Now the response packet, when the network packet comes back to me, now have to say, who do I route this to? All my job is routing essentially packets. I'll take the packet and send it out. And then when I get the packet back, and I have to be able to say, okay, this request was originally, requested by the database one. So I'll give the response back to this guy. So it will do that source and destination check, okay, for every EC2 instance. But the NAT instance acting as a proxy, so it should not be done just for that. Does it make sense?
Venkat.
Yes.
So if we are doing netting and we set it up, as far as I understand, like we put it on a complete public, we added in the public subnet, and obviously all the routing on this public subnet would be through netting. It means in my public subnet as well as my private subnet, everything is going through netting. In that case, we are adding a latency on public subnet as well at the same time, right? Because netting would cause some latency, right? It would convert, or it would do some. So we are adding a latency on public subnet as well at the same time.
See, we are talking about this natting happens at the layer 4 level, at the IP level. Okay, the network level, any of these network level components, they can handle millions of requests per second. So the latency is negligible. Today, that is how you are able to send it. When you make an internet connection from your laptop in your home network, do you know what exactly is going on there? It's the same thing. So when you go out, okay, within your LAN, you don't have internet. So you have to go through the router, correct?
Yes.
Your router will identify that, okay, I have 10 machines here. Let's say you have an Apple TV, you have your iPhone, and you have your, Lenovo laptop. So it has to be able to find out, okay, this packet was originated from, who originated it. Okay. And then when it sends out, it will send it, it acts as a proxy there. Your router in your home network is acting as a proxy and then sends the request on behalf of you guys to outside. When the response packet came back, it has to be able to send it to the appropriate guy. It can't send the packet when originated from Lenovo laptop. It can't send it to your Apple TV, right? You see what I'm saying?
Yes.
So that's where all the magic happens. If you look at the layer 4 level, layer 4 only contains your IP address and IP NATing, all that stuff. And each packet has that. Where was it originated from, but where is it destined to go? And who are all in between. In between, okay, by the way, I'm glad you asked that question. So from your local machine, from your Apple TV to your router, and then from router, by the time it goes to your Netflix and comes back, how many hops, how many places it will go? Every single place, the network address translation happens. So it goes to your, WAV network. That's your internet provider. From there, it goes to the next level. It goes to the, somewhere in between, and then it goes to eventually your Netflix server. And within that, there are multiple routers there. You see what I'm saying? It at least stops your packet will be stopped and manipulated 10 places in between from the source to destination. Okay, I believe they call it layering. Okay, so so my NAT instance is good. So my NAT instance is in my public subnet, and my public subnet has access to this guy. Okay, my NAT instance. Now my DB server is inside private subnet, and private subnet, sorry, route table to my NAT instance, this 341DE. Okay, now we should be able to get the internet. Let's go connect to it. Looks like we're already connected. Is that why? Sorry. Okay, so SH EC2 user 10.0.2. something. My DB server 203. Thank you. Minus -i. Okay. No, I think it's going to time out.
But why are we still going through our web server, That we're supposed to log in directly to the DB server now, right?
No. This is, we still want the protection for our private subnet resources, right?
Oh, so we still have
So
to
you still don't want to be able to log in. No. We don't want the traffic in, but we want traffic out, because we want to be able to, patch our operating systems. We want to be able to install our, database servers, everything. So that's why I need the internet out. I need to be able to go out and get the packets from internet. You understand?
Yep.
But I still don't want any public network in. Okay, so it failed, right? So why did it fail? So this is our F1D0E. This is our NAT instance. Actually, this guy does not have a public IP. Could that be the reason? Let's take a look at it. Let's go to route tables. Yep, route table has a proper edit route table association. Oops, not route table association, but let's go to route tables and we have our main route table. Okay, subnet association. Private subnet is associated to this guy. Makes sense. Private subnet is associated, but what are all the routes? Sure. This is our NAT instances for F1D0E. Yeah, this is anything there? No. This is our EC2 instance, NAT instance. The only one thing I see is it does not have a public DNS and it needs a public IP. So when I created this NAT instance, I did not select the public IP to be given. So let me go ahead and do that. Let's create a new NAT instance. Okay, see here, network is custom VPC. Your subnet is, yep, I want my NAT instance to be in public subnet. Auto assign public IP, please enable it. Okay, I could have done this at the subnet level, the subnet default setting also. If I enabled it at the default subnet level, then I don't have to select this every single time. Okay, and then, oops, did I come from a proper, no. Did I come from a proper AMI? No, right?
No, Venkat, didn't come. You didn't go to a NAT.
I didn't go to community.
No, you didn't go to NAT, absolutely. Yes.
So let's go ahead and select this guy. EBS, NAT, HVM, yeah, this makes sense. General purpose, sure, T2 micro is fine. Network is custom VPC. Subnet, it must be public. And then I want public IP. Okay, add storage. I'll call this as NAT instance 2. NAT instance 2. Security group, and I want the public. So don't worry, we will, I'll make sure you do this fully, and it is very important for the exam and the real life to be able to do this from memory, okay, without having to look at some instructions on your side, okay? It's that important, the entire, the concepts. I know we didn't talk about the NACL, network address control list. That's another beautiful concept. We'll talk about it, but I want you to really spend time and do it. I will not even proceed without you be in that comfort zone. It's that important. Okay, so the main route table, edit routes. Let me go ahead and clear the route. Okay, internet NAT instance, my NAT instance 2. Close. Okay. Now my NAT instance 2 is coming up. Let's wait for a second. Let's wait. Meanwhile, we can.
Don't you have to turn off that source destination check?
Oh, thank you. Appreciate it. Thank you, sir. Networking, change source destination check. There you go. There you go. There you go. Did you see that? And you can do anything here. Sudo yum install. I know I don't mean to install HTTPD on my database server, but I wanted to show you the fact that it's able to connect to internet now. It's able to connect to internet. It's able to get the packets in, and then yep, you'll be able to patch your operating system. You'll be able to install your database servers. You'll be able to do anything. So you have internet now on your, even though they are private, they are secure in their own private subnet. There is no internet packet. Outside guy cannot come in, but these guys can go out through NAT instance. See this one here? So every packet here, whoever wants internet within, from this private subnet, they have to go through the NAT instance that is in a public subnet. Okay, has to go out. But the biggest disadvantage, this absolutely works, but the biggest disadvantage is that if I have 10,000 servers in my private subnets, okay, and if I have a couple of NAT instances, well, I can apply the auto scaling group and all the high availability architectural principles here, but you are managing everything, right? So this is an EC2 instance, you're managing it. So Amazon has it for a long time. They highly discourage using NAT instances now. Rather, they created another appliance called NAT Gateway. Use the gateway that's horizontally scalable without you having to worry about it's acting as a gateway. Okay, you just create it, attach it, and change your routing policies. Pretty much, you get your internet for your resources in the private subnet, but you have a fault tolerant NAT gateway. So you are not depending on a simple EC2 instance, guys. Okay, so I will show you that one also. If you guys don't mind, let's spend another 10 minutes. We'll finish that, and then we'll take a break, and then pretty much I'm done talking. I want you to do it, and then pretty much I'll help you throughout, and that's my objective. Okay,
Venkat?
Yes.
So so right now you went through the database server through the web server, correct?
Yes, I'm logging in.
Yeah, so real life scenario, basically it could be done by a script, so you would not have to log in, correct?
Actually, I do not recommend going this way because I stored my private key in my web server, right? I do not recommend this. Rather, I will show you that in the next class. Okay, there is a different way you can do it. There is something called Bastion host.
Okay.
So using that, it acts as a jump box. It acts as a hoop. For example, you'll be able to log in to your database server through Bastion host. Okay. I do not recommend this approach because you are storing your private key. You do not recommend, I do not recommend, and AWS does not recommend so. Okay. So this is just a temporary solution until we talk about Bastion host. But before we talk about Bastion host, there is, a couple more topics that we need to talk. So hang in there. Yeah. Okay. So I told you why we don't want to do the NAT instance. Okay. If I have 1,000 database, not just the database servers, hundreds of servers, if they all go out, okay, pretty much every single packet is going through or proxied through NAT instance. It's a simple EC2 instance. It's not a good idea. So please do not use NAT instance, but unfortunately they keep coming in the exam. So, we'll be prepared for that. But definitely in 2020, when you are in the year 2020, when you are finding a solution for that, do not go for NAT instance. You rather use NAT gateway. So I'll show you how to do that. Go to VPC. It's another simple, like everything else with AWS. If it's complicated, it's not AWS. It's that simple. So NAT gateways. Click on your NAT gateways. Create a NAT gateway. And where do you want to put this one? your NAT instance or NAT gateway must always be in public subnet only. Resources in the private subnet, they go through either NAT instance or NAT gateway that reside in public subnet. Does it make sense, guys? Only because only they are attached to the internet gateway. Does it make sense? I'm actually acting one more proxy, that's all.
It
Either
does,
through
but why are we getting an option of a private gateway subnet here? Because that system doesn't know that what is public and private as on custom one.
Because your use case may be different, right? Your use case may be different. So, you know, if you have a multiple, let's say, see, in this case, how does it know that it's a public or private? Not through the name, right?
Not through the name, but maybe from the internet, right? We connected IG double is there, so from that it would be figure out, oh, it has the internet access and it's a public or maybe
yeah, but see, it's not the direct association, right? Your subnet is associated with the routing table. That routing table has a route out to IGW. That is when your subnet is called a public subnet.
Yep, got it. Yep,
okay.
I see now. Yep, I see there is
so
a layer
it's
in between.
yeah, exactly. It's not that straightforward.
Yeah, I see that.
Not through the name.
Yep, I got it now. Yep.
And then you have you know, multiple VPCs. You can put it anywhere. You know, this is for, these two are for the custom VPC, and these three are for default VPC. So it doesn't know. So I'll click on the public subnet, and then elastic IP allocated. Did you guys see why the NAT instance did not work for the first time? Because we did not assign a public IP. So public IP is a must for your NAT instance or NAT gateway. See this one, elastic IP allocation ID. So, well, we don't have, if I have any elastic IPs, you can reuse it, or you can say, you know, allocate one for me. It will allocate it automatically. What it's doing is it is allocating an elastic IP to your NAT gateway. You know what I mean by elastic IP, right? Elastic IP is a static IP address. Remember, I told you when I talked to you about Route 53, please do not use your regular public IP, because every single time your EC2 instance gets rebooted, your public IP gets changed. So that's why, if you really want to use this in your A record, go for your elastic IP, assign it to your EC2 instance and put it, okay, elastic IP. This is your public IP. You understand what I'm saying there? NAT gateway. Okay, I created a NAT gateway. Now I got the NAT gateway. Okay, it takes a few minutes. Let's wait. And what's the next thing I have to do? By creating a NAT gateway in my public subnet, will it automatically give me internet to my database servers?
I think you need to configure a database server to talk to them, right? So we need to add in database server that gateway, right?
Do I configure my database server to do that, or how?
Route. So from database server, you have to configure the route to go to the net gateway.
Yep, you are very close. So these database servers are, all these database servers are in a logical IP range called subnet, right? This is a private subnet. All these guys have a subnet, and you have your rules associated in the form of this is your route table. Your route table is attached to your private subnet. So change your route table routes and attach your NAT gateway. Does it make sense? Like how we just attached NAT instance. So let's go to route table, and let's go to main route table, because main route table is where currently your NAT instance is attached. Remove this guy, add route, and then go to NAT gateway, and you have one NAT gateway, save it. That's it. Because your main route table is associated with your private subnet, all the resources in your private subnet will go through now the NAT gateway proxy, and that NAT gateway is in a public subnet, and the public subnet has a route to internet gateway. Internet gateway is acting as a proxy for the entire VPC. You can only have one internet gateway per VPC, and it will give you internet. Does it make sense? That's how you get it. Okay, so this one makes sense, right? Now, pretty much your behavior should not change. You go back to your this guy. I can close it and I can come back to EC2 and then log into web server. At this point, I don't have any option, but I have to log into web server first and then log into DB2 because we did not talk about Bastion host. sh ec2-user at 10.0.2.203 minus I. Very good. Very good. No packet. That's it. You have internet. You can, if you want to test something else, Amazon, Linux extras, Tomcat. Let's see. Oops. Tomcat is not found. Okay. Okay. You understand what I'm trying to do there. Tomcat 8.5. That's it. So you have access to your internet, but nobody else can talk to it. Meaning outside of your VPC cannot talk to it. So all of your private resources are very secured. Okay. Nobody can, not even one network packet can come in. So that's the beauty. So you got your full security there. And yeah, that's it, guys. Any questions? And this one probably, it will complete now. Take a look at it now. You have your public subnet, you have your NAT gateway that's placed in the public subnet, and you have your database servers in your private subnet. And these guys can go out to internet. It goes to the router will check that, okay, you want to go out, sure. So you want to go out, then you have to proxy through NAT gateway. That's what my route says here. See here, this is my custom route. See this one? Here my route says that you have to go through your NAT gateway. So, okay, let me take this request to the NAT gateway. NAT gateway will NAT it. Did you understand? NAT gateway will essentially NAT that packet. Network address translate that packet and then send it out to the internet gateway. On the way back, again, it gets to, NAT gateway, and then it does the source, again, renatting, and then give the response back to the database server. It does at the packet level. You don't have to worry about it. But essentially, that's what the concepts are, guys. Make sense? Now, in the class, you will do it. I'll not let you go without you being able to do it. I'll guide you through it. We'll take a break, and after that, I really want you to do it. And there's a couple more concepts that we'll talk tomorrow. Okay. Let me stop the recording here. Stop recording.